In this video, we're going to focus on two ideas. The first idea is identifying the largest and smallest sides in a triangle, and the second concept is to use the Triangle Inequality Theorem. When you're identifying the largest and smallest sides, you need to keep this in mind. The largest side lies opposite the largest angle. On the same note, the smallest side lies opposite the smallest angle. Let's put this idea to use. The first question on our worksheet asks us to name the largest and smallest angle in each triangle. In triangle SUT, we have three sides. SU is 21, UT is 16, and ST is 25. Your largest angle will be the one opposite the largest side. If the largest side is our 25, the angle opposite or across from that would be angle U. The smallest side, the smallest angle, will be across from the smallest side. Our smallest side is TU, which is 16. If we're looking opposite or across from TU, we look to angle S. And the second problem. Triangle LJK has three sides. The lengths are 8, 11, and 16. The large angle will be across from the largest side, our largest side being 16. This angle opposite 16 would be J. And our smallest angle lies opposite the smallest side. The smallest side is side JL, which is 8. The opposite angle to that would be angle K. When you're asking you to name sides, you just do the opposite. In triangle TUV, we have three angles, 53 degrees, 52 degrees, and 75 degrees. The longest side will be the side that's opposite angle V, which is the largest one, 75 degrees. We're going to call that side TU. You could also call it side UT. But when you're labeling that, make sure you put the line segment above it. Our short side is going to be the one opposite the shortest angle, smallest angle. Our smallest angle is 52 degrees at angle U. The side opposite that would be TV. Again, put your segment on top. In problem 7, we have angle XY, triangle XYZ. 55 degrees, 65 degrees, 60 degrees. The longest side lies across from the largest angle. The largest angle being angle Y. We look at the side that's opposite that, which would be XZ. The shortest side would be the side that is opposite the smallest angle. Angle X is our smallest angle at 55 degrees. The side that's opposite 55 degrees would be side YZ. Let's put our other concept to use here. The Triangle Inequality Theorem says that the sum of two sides of a triangle must be greater than, just gonna put the little symbol in there, greater than the third side. What does that mean? Let's use this in practice here. On the reverse side of our worksheet, they ask us to state if the three numbers can be the measures of the sides of a triangle. What we need to do is add the pairs to see if they're greater than the third. So if we say 9 plus 12, the question is it bigger than 11? Well, 9 plus 12 is 21. It's bigger than 11. Check. 12 plus 11. Is that bigger than 9? Definitely true. And our last option is 9 plus 11. Is that bigger than 12? 9 plus 11 is 20. 20 is larger than 12. The answer is yes. This can be a triangle. For the next triangle, we're looking to see if 2, 12, and 10 could be the sides of a triangle. Well, if I test 2 plus 12, that's 14, which is bigger than the third side, 10. True. If I test 12 plus 10, that's 22, which is larger than the third number, 2. Check. If I say 2 plus 10, we're asking if that's larger than 12. Well, 12 is not larger than 12, it's the same thing. That does not work. The answer for this triangle is no. The third side must be greater than, it can't be equal. Let's look at our other examples. It says two sides of a triangle have the following measures. Find the range of possible measures for the third side. Well, the two sides they're giving us are 6 and 12. Again, we need a range. The way we're going to write our range is with a set of inequalities. It's called the compound inequality. To find the number on the left over here, you subtract your numbers. To find the number over here on the right, you add your two numbers. So if we subtract 12, take away 6, that's 6. If I do 12 plus 6, that's 18. That means for this triangle, any side length between 6 and 18, not including those numbers, will work. Let's look at our second set. They give us two numbers, 11 and 11. Again, put your inequality there. To get the number on the left over here, we subtract. 11 take away 11, 0. 11 plus 11 gives us 22, which means any number, any side length that's larger than 0 but smaller than 22 will work and form a triangle.